Right, hi Louisa. Question 9 of the statistics. I know you only asked about part C. I'm going to go through quite a bit of the question because I suspect there'll be a few questions on it. It's a weird question in as much as it's a bit of an old-fashioned. It's quite old-fashioned mathematics. Like there used to be a reason for the ln of y. And the way of checking to see if there's an exponential relationship when you didn't have calculators. So to some degree, it's a bit of a question. Now we have got calculators, but there we go. So I'll talk you through it from the start, and then we'll see how it goes. So I've got the on the calculator. Let's make this bigger. Okay. So I've put in x, the x values, put in the y values. I've done z as ln of y, which is what I asked you to do in the question. And then it says find a linear regression. It's z and x, so ln y. I'm trying to find a linear regression between those two. So I've done normal stuff on the calculator. I found a and b. And then I've written it. So I'll click on this. Okay, hopefully that's come up for you now. So I've just written down the relationship. So the relationship between z and x was 0.1216x plus 4.9615, which means that ln y would equal that because z is ln y. Then I've done a bit of manipulation. I've said, right, okay, if ln y equals all that stuff on the right hand side, then y would equal e to the power of the right hand side, just our basic logarithm rules. And also because when we do, like x squared times x to the power of 5 would be x to the power of 7, we'd add those powers together. So similarly, I can break it down into e to the 4.9615 times e to the 0.1216x. Because if I times those two things together, I'd add the powers and I'd end up with the line before with the 0.1216x plus 4.9615. But e to the power of 4.9615 is just a number, and I've worked that out. And so I've ended up with this relationship between y and x, which is part B, where it says y equals 142.808 times e to the power of 0.1216x. Okay, so hopefully you followed all that. It's a bit weird, I've got to say, but I think that's what it's looking for. Incidentally, I'll just go back to the calculator. Alright, wait a few seconds, hopefully that's come through. And I'm going to change the screen to here. Okay, if you open up that data and statistics page of the calculator, and you look at the graph of x and y, you change those variables for x and y, you see you get the circles, and also in menu it's analyze graph for the one before. I think it's menu 3 or menu 4. I can't quite remember. But you can plot a function in there. So I've just put in the function that we found, just to have a look at it and make sure it fits the data. And you can see it fits pretty well. It's like it does look like an exponential correlation between these two sets of data. And when we put the one we found in, it looks like it fits quite nicely. As it happens on mine, it's got it stored as f5 of x. So the last thing I've done, hang on. Okay, hopefully that's come across. The last thing I've done, it's saying, and this is the bit you actually asked about, sorry, was find out what CA was, what Y was, when the year was 2005. Well, that's when X will be 12, 2 years after 2003. So I've just put F5, the function that I've defined already, and I've put X into that, and it's given me a value of 614.434. So that would be the answer to C. So that's the steps that I'd take to solve it. But like I said, it's a bit of a weird question. It's sort of, there was historical reasons for doing this sort of stuff, but really there's no point anymore, but there we go, at least we know how to do it, I hope. Okay,